And we're live.
Hey, good morning, good afternoon, and good evening. Hope all of you are doing well. We're resuming the NoCode series, which we actually have not been offline. We've been involved in a boot camp, which I've been mentioning before, the LLM boot camp with Apache Cassandra. And today I'm just going to be doing a repeat of what I did yesterday because it's more in line with the NoCode theme of this channel and with this meetup group. Thanks, Akwi, for recording and taking care of all this. As I mentioned in the past, I'm going to try to explain as much with audio detail so that if you're listening to this on your way home from work on YouTube or maybe in the future in a podcast, that hopefully you'll get a few core ideas of what I'm trying to explain here. In the last few weeks or 3 or 4 weeks, there have been a lot of advancements in the LM world. And just to quickly catch you up, these are the things that are kind of in my top of mind right now. So one is Microsoft is going to be partnering with Meta to provide hosted Llama 2 models. Llama is the open model that Facebook gave out to people, and a lot of people made tunings of it with Vicuna and Alpaca. So Llama 2 is the next version. And they're going to be partnering with Microsoft. Meta, meaning Facebook, is going to partner with Microsoft to offer this to folks in the enterprise world. I just read earlier that Apple is going to be also coming out with their own Apple GPT. And why is this important? It's important because, quite frankly, machine learning, data science have been around. A lot of companies have been using it. LLMs are the most practical way that regular people can use it. So if you're a tech company and you're not on the LLM bandwagon, something is wrong. So I'm glad that these partnerships are happening, that Apple is getting into the game. Hopefully that will create competition to make better LLMs in the future. DataStax's Astra vector search is now general availability, got released yesterday. I'm actually going to be showing that to you today in how to use it to do some retrieval augmentation, meaning how to talk to your data. And one of the tools that I'm also going to show you today is called ChainLit, which is a user interface framework for making not really chat bots, but just basically chat interfaces that you can use to work with these open source frameworks like LangChain, LlamaIndex, or just directly talk to OpenAI. And since it's a Python framework, technically you can use it to do any type of chat application. So I thought I had this presentation already ready to go, but let me go ahead and pull it up. There we go. And then while I do that, beside all the public open APIs like OpenAI, Cohere, Anthropic, these cloud instances available on Azure, OpenAI, Azure Llama 2, Google has also put stuff out there with Palm 2, which is a pretty good model. Amazon, as I mentioned in the past, has put out their AWS Bedrock. Alongside all these publicly available public cloud LLMs, there's also a lot of cool stuff coming out in the open source world, which is how do you host or manage your own open LLMs. So there's a framework called OpenLLM, which hopefully in the future I'll show you guys how to use with LangChain, which is kind of a de facto framework right now, and with other frameworks. I think I'm ready to show. There we go. And Akwi, just let me know if it is visible.
Yep, it's visible.
All right, great. If you've been following along with the bootcamp, or with the previous, videos on this series, you'll be all caught up. Today, I'm going to do a quick, reiteration of, when to use a framework, why to use it, and then we're going to dive into some code, hopefully not a lot of code, and to explain, how to leverage things like LangChain, how to leverage things like LLM Index, when to use it. If you're not in the LLM world right now, ChatGPT is probably the first thing and the last thing that you've heard about, but the technology behind ChatGPT, it's a type of AI called generative AI, and in generative AI, large language models are a type of generative AI that basically you give it text and it gives you stuff back. Now, what it gives you back seems like a human being, seems pretty intelligent. But because it's an API, because it's a system that a computer can talk to, and not just you using it via a chat interface, it can help us do two things beyond what, let's say, ChatGPT can do. Now, ChatGPT also has some of the stuff I'm about to talk about with their plugin ecosystem, but ChatGPT is not the only game in town. There are other models. And if you wanted to make chat bots or chat programs that help people with your own data, likely you wouldn't necessarily just use ChatGPT. You would use something that you create or some other ChatGPT clones, which allow you to talk to data. The reality is that this is, if you're a software engineer and you have some data engineering background, or if you're a data engineer and you have some software engineering background, you can do this relatively easily with the tools that are out there. Now, what can you do quickly that everybody else is doing to prove that you can, work with LLMs? One is retrieval augmentation, and the other is agency, creating agents. Retrieval augmentation being that when you ask a question to the LLM, it's not just giving you an answer based on what it's been trained on previously, but rather it is giving you an answer based on data that is relevant to your question. And that data could be coming from an outside system, like a search on Google, or Weather API, or Foursquare. It could also be your own data. So retrieval augmentation kind of covers this broad aspect of talking to an LLM, but enhancing the LLM's ability to give me an accurate answer with data that I've retrieved from somewhere else. So that's why it's called retrieval augmentation. It was also called data augmentation before, but technically retrieval augmentation is more comprehensive. It doesn't just mean data. It could be like a database. It could be images. It could be audio. It could be video. And we'll get into that much later. Agency, which is to be able to act on behalf of you, is where the LLM itself can't do anything for you unless it is connected to something like the ChatGPT plugin ecosystem, or if you're using a framework like LangChain, or actually in LLM Index now it has some agency as well to do things for you, right? Because all the LLM does is just, you give it text and it gives you text back. You need to do something on your own to be able to talk with outside systems to do things for you. Shameless plug, really grateful for all the customers we work with. I work with Anant, and Kono is a focused service and training company that just helps people with LLMs based on our experience with data and business platforms in general. We've had the opportunity working with a lot of the companies that you experience on a day-to-day basis. And I want to just give a shout out to all of our customers for helping us have jobs. The bootcamp link, we continue to take feedback on where we should be holding the physical boot camps, which we have not done yet. Also, what kind of things you're interested in and what kind of things you want to learn. So check it out. We're almost done with the first public bootcamp, which is being delivered virtually. So sessions 1 through 4 have already happened. Session number 5 is next week. And we will give you the link if you want to, register. And actually, we'll also drop the Discord link so that you can continue talking to us and to me about this stuff if you want, and ask questions if you want, beyond the YouTube chat today. The agenda of the bootcamp, we've covered a lot of the strategy and theory and LLM design patterns in this channel, in this meetup. We've talked a little bit about the no-code code stacks. We're going to talk more about it today. And we're iterating towards helping you create your own chatbot with your own data. Today, we're going to do a quick review of retrieval augmentation. What does that mean? We're going to take a look at some common patterns of what an LLM inside app actually is, what it means, how to go about it. And we're going to look at some code, which is publicly available for you to download and try this out on your own. Before LLM or LLM engineering, machine learning was hard. You have to do pretty decent data engineering with streaming or data or batch data processing. You had to have a pretty good software engineering background and work with essentially APIs. And in the middle, to train a model, you had to train and serve up these models on your own. These days, this middle portion is optional because the public LLM providers like OpenAI, Azure, etc., they do this for you, and the models are pretty good, so you don't have to train and serve your own to train and serve your own LLM models, though you can, but it's optional because the model, it's a foundational model, it's pretty good, and you can tune it and train it, quote unquote, with your own data without necessarily training a machine learning model in the traditional sense. And that's by basically having data in vector databases and then having good prompts that can talk to that data and make sense of it. What is retrieval augmentation? Well, there's basic augmentation with just data of any type. Then there's vectorized data augmentation, which is what makes it a little bit more practical for people. And then there's some general patterns and architectures for how this works. So information retrieval is a loaded term. It's in computer science. It's basically how do you get data out of a database, right? With LLMs, it means to augment an LLM, what we're really doing is we're taking a question a person may ask and going to an information retrieval system, which could be a database or an API or a search index, getting relevant documents, constructing a prompt with basically the question the user asked, the context of what data that came back from the retrieval system, and some other prompt that says, hey, use this information to answer this question. And we've talked about prompt engineering in the past, so we're not going to reiterate that today. And it takes that prompt, that constructed prompt, sends it to the LLM, gets an answer, and then sends it back to the user. This process looks like this. User asks a question, some framework, you don't have to use a framework, you can just use your own code, and that's your framework, constructs this prompt by first getting the data from a database, sends it to the LLM, gets the answer back, and sends it back to you. Pretty simple. And you can get by with doing this on your own. In fact, the very first examples I was looking at back in December and January, people were doing this with, let's say, podcast transcripts from Andrew Huberman's Huberman Labs podcast, putting it into Elasticsearch, and basically having a Andy Huberman chatbot. And now there's companies that do this, but back in December and January, it was pretty cool. But it was basically this, right? That was all it was. Vector information retrieval augmentation is two parts. One is that the vector database needs to have our data stored in a way that we can get similar documents later. Now, in the past, I've explained how vector databases are great for AI, for being the memory of an AI. I'm not going to get into that today. It'll take too long. But to get the data into a vector database, we have several pieces of data. Our framework, our code, basically talks to an LLM. It doesn't have to. It can actually use an open model from, let's say, Hugging Face, gets embeddings, which are basically the words of that text that you gave it, encoded as vectors. Because inside the LLMs itself, that's what happens. And those vectors get stored in the vector database. Those vectors basically represent, in some n-dimensional mathematical space, it represents this document. And when we have a question and we actually embed it, again, using the same model, we can look for similar documents from the vector database. Basically, the user asks a question, our framework goes to the LLM, embeds it, gets the vectors back, finds similar documents using those vectors, retrieves the documents, augments the prompt, gets the answer from the LLM, gets it back, and then sends it back to the user. So not that different, except that we have to pre-vectorize the data or pre-embed, whichever one you call it, and then we have to embed the question every time we ask it. And so if you wanted to do this yourself, you wouldn't do it yourself. You would use a framework like Llama Index. So in this case, we have data coming from Slack, Google Docs, and some CRM. We can use Llama Index because it has some connectors. It takes it, it indexes it, stores the data, the text, as well as the vectors. Using some chunking process, it can summarize it for very, very long documents. We need to summarize it and have it in a hierarchy, and it loads it into the vector database. So all this can be done inside the Llama Index framework. We don't have to do all this. I'll tell it where the vector database is, basically. And then on the retrieval side, it actually takes the user query, embeds it, goes to the vector database, gets similar documents, goes to the LLM to basically look at that relevant data, answers your question for you, and then gives it back to you as a user. So if Llama Index does it for you, why would you want to do it yourself? You may have a good reason. I don't know what that is right now. But do you have to actually use these frameworks? That's a good question. I'm going to make a case for not having to use it, and I'm going to make a case for using it. And you'll see why. One of the first applications that I created with OpenAI API was actually a Bubble application using Airtable for some information, and then using Astra, which is a database as a service, to have a REST API. So as long as there's a REST API, you can use Bubble to connect to it, right? Bubble is a no-code platform to make applications without programming. You have to know some logic, but it's pretty good. But you don't have to use Bubble. You can use anything, right? You can use Flutter Flow, which is a no-code tool to make Flutter apps. You could use technically WordPress if you want. Anyways, the software layer in a no-code application is the actual no-code platform. It gives you the ability to sequence instructions. So, for example, if a user inputs something, in the Bubble app, it's called a workflow. And a step in the workflow would be to take the user's question and maybe take it, send it to OpenAI with a prompt around it. OpenAI gives a response back. You can store it in a database for history purposes, for example, and then you can show it to the user. Okay. Or you can do the same thing. You can retrieve the data from Airtable, do some processing with OpenAI, send it back to Airtable. So the software layer in a no-code application is basically in the actual no-code platform. Data, where does the data go? It depends on where you want it to go. OpenAI is just an API. It doesn't store any information for you, so you have to have some other place to store it. Airtable connects relatively well with Bubble. So does any REST APIs. You could use DataStax, you could use Supabase. It really doesn't matter, as long as it's an API, a backend API. Database as a service, if you will. And anything else that you want to connect, you can connect to no-code platform. So it works. You can make a ChatGPT clone with Bubble if you wanted to. I don't know why you'd want to, because there's so many ChatGPT clones, but let's just say you wanted to do it and share it with your team members. You could do that relatively quickly. You can also, and notice that there's no LangChain or Llama index here, right? You can also make your own front end using, let's say, React or Vue. You can make your own API that then wraps some third-party database and OpenAI. And your React app basically talks to your API. Your API talks to OpenAI and any other database that you want to talk to. Traditional software engineering. Basic front end, back end, what people call full stack. Your API would basically wrap the prompts, right? Where is the data going to go? You could store it in a database like DataStax, Supabase, Firebase, depends on what you're comfortable with. I like Astra DataStax because we're partnered with DataStax, and it's a very, 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 very fast, big database available as an API. So I'm all about it. And it's open core, meaning I know exactly how it's built because they open source all this stuff. Systems, what other systems? So if you're doing any API engineering, you can connect anything you want, right? Again, no framework, no Llama index here. You can also do background process automation using NoCode with OpenAI or any other LLM API, if it's available as an API. In Make, previously known as Integromat, I was able to, and I think I've shown a demo of this before, take some data from Airtable as it watches for new records. It then takes one field from the Airtable and does a prompt around one field here, field 2, field 3, field 4, gets a response from LLM, from OpenAI, and it saves it in different fields. So one input wrapped with a prompt 4 different ways can give us 4 different values. Simple reason for why this is useful for me. I can have a basically topic, and I can say, based on this topic, write me the title for a particular blog post. And based on that topic, write me a blog post. Write me the meta description. Write me the slug that I want to store it in some publishing system like Webflow or WordPress. So I can automate the task of writing one blog post, but technically with this, I can have it automate the task of writing 1,000 blog posts. There's actually tools out there that you pay, but you can actually do this quickly with Make. And if you use OpenAI or Zapier, Make or Zapier, they already have OpenAI integration, so it works relatively easy. Again, no LangChain or Llama index. This is just a no-code platform. You can do the same thing that I'm showing here in Python in any programming language, because any programming language has a way to talk to OpenAI, either using some library or using the OpenAI REST API. So in this case, I have a method where, given a particular, I'll call it a super prompt, it creates basically 10 or so topics, right? And I get this back. And I can refine prompts to get it to do exactly what I want, but this is a reusable method I can use. Once I have it, I can use it again. So if you're using ready-made packages like OpenAI or Airtable, you can basically do this in some Python code. And if you make helpers, you can reuse this code, right? Here's another reusable Python method called get blog post. So given the topic, which is an output of the previous step, I can then create the blog post slug, and it goes on and on. And actually, there's like 4 pieces of code like this that basically uses OpenAI to get answers. And then eventually it returns the title, the contents, the meta description, the keywords, and the slug. And I can save that back into Airtable. So I can say, here's my record, right? Take the name, and this get blog post basically gets all these data points from this method. And I can just save that into Airtable, right? So essentially, an Airtable plus this code and all this, I can do 1,000 blog posts in an hour no LLM, no LangChain, no llama index, just plain old Python, Airtable library, and a OpenAI library. And I don't know if you could see this, but this is 10.1030, so 1,030 posts. And it was created relatively quickly. And I actually added some code later to find pictures, relevant pictures, and get the description so that it's not just content, it's content and pictures, right? No LangChain, no llama index. So you can do a lot. So if you can do a lot with direct API with tools, you can quickly automate, obviously, you can validate things. But if you're using no code, you have to do a lot of point and click. But if you're a non-technical person, you can prototype these things, and you can do this without necessarily having a programming background. However, retrieval augmentation is hard. You really have to do a lot of work yourself to do retrieval augmentation. And it's also hard to do agency, meaning it's not going to be intelligently able to take actions. You have to tell it, hey, do this, do this, do this, right? It works, but you have to know exactly what it needs it to do. Then technically it's not an agent, it's just a program, right? Now, if you use a framework like Llama Index, you can have your data, you can have the LLM API. Using Llama Index, you can create your own API. You can create your own automation or your app. And then you can also use Llama Index with LangChain. The retrieval augmentation here is relatively easy, meaning you put data in, you can ask questions against the data. It's relatively easy to use if you're a Python programmer. So there's no code version of Llama Index yet. Maybe somebody will create it, maybe we'll open source something ourselves. Cons, it's only in Python. As I said, there's no other frameworks that do Llama Index type stuff in other languages. I guess LangChain has some qualities of this. But what I like about it is it's purely index management, but it's also a con. It only does this data management for you, and you can ask questions against your data, but that's about it. There's some agency, which I'll show in a second, but for the most part, it's retrieval augmentation only. LangChain, on the other hand, allows you to do third-party APIs, and we'll take a look at that today. And again, you can make your own API with LangChain. You can do automations. You can make your own app, and then you can add your data to LangChain. You don't need to have Llama Index, but you can also do your data with LangChain and then your data with Llama Index. So here, agency is easy. It's available in Python and JavaScript. Retrieval augmentation is easy. There are some no-code tools that work with LangChain. So LangFlow works with the Python version of LangChain, and Flowwise works with the JavaScript version of LangChain. Also, when I'm going to show you today, ChainLit also works with LangChain, and actually works with Llama Index as well. You got to know the concepts to really be a pro user. So if you know Python, great, but then you have to learn what LangChain components are, but that's okay. And it's easy to write bad code, but that's okay. You can learn as you go along. Just remember that the same principles in writing code in any language apply to writing code with LangChain. It's just about modularization, separation of concerns. So LangChain by itself is pretty good. Just if you learn how to use it well, you'll be you can create pretty powerful stuff. But the other con, even though there's agency, sometimes the agents don't act exactly the way that you expect them to behave, and there's ways to tune it. But that's what agents are. They act on their own. So we're going to take a look at some hands-on code using LangChain, ChainLit, and a library called Casio. And not be able to get to the view interface, but we're going to take a look at the ChainLit interface. So a couple of prerequisites. First, if you are curious to follow along, this code is available. I know you'll be able to follow along, but you can watch the video later and follow along. And basically, it's a reference chat program. There's two of them actually. One is a view application with an API, and another is a ChainLit application. They both use LangChain right now, and we're going to add Llama Index to it next week. But to make it work, you basically have to get an OpenAI key, a SERP key, a Giphy key, a News API key, the movie database key, Wolfram Alpha. You don't need the Google stuff, the Foursquare API key, and then Astra keys if you want to store data in a database and ask it questions. So I've done all this, and I don't need to do it again. But this is stuff you can do on your own. And what you end up doing is in a file like this, you'll fill out all your secrets. Okay. And I'm going to be updating the README to basically have the full bootcamp, a series of homeworks and one tree, basically. So by the time this is published, and by the time you watch the next one, you will have everything in kind of one order. And if you can also send this link to the chat, Akwi, please do. And if you have questions about this code, you can ask on the Discord channel that Akwi is also going to link. Okay. So I went through the, did the homework. I got all these keys. I saved them in my file. I'm not going to show that because there's some secrets in there. And very quickly, I'm going to run ChainLit, and I'm going to run ChainLit right now, and then I'm going to walk through it later because I want to, explain what ChainLit is doing for us first, and that's when we can look at the code so you can see kind of what's happening in the background. Don't worry about these warnings; it's okay. So I'm using Gitpod actually with. I have to make it public. No, it looks like it. I have to do this. I have to do this every time. If you're familiar with Python, I just had to reinstall the requirements, and I'm running my app. Did not, it failed. Let's see. Let me try something else. It literally was working for me earlier. Maybe if I do this. Okay, and I'm gonna just do pip uninstall. Clean everything, and I'm gonna start off again. And while that's happening, these are the libraries that are in this. Some of them are just for the ChainLit demo that I'm going to show you. Some of them are for the API with Flask. But some of these are actually used in both the ChainLit application and the Vue app. So Guess I have to add this to my GitHub YAML. Yeah, always improving. And then now if I run it, it should work. It is still having issues. So you know what I'm going to do? I'm going to open this Gitpod on the browser because I'm running it in my computer, and Gitpod in the browser generally is more consistent, and so that way I can resolve this issue at another point. It's one of my favorite things about Gitpod. I know that if it's working in Gitpod, generally it works pretty well. So well, it looks like it may still have this issue. Let's see. You know what I'm going to do? I'm just going to remove the cache. Just gonna and that Prisma has a dependency. So I'm gonna actually make a quick reset of ChainLit, and what I'm going to do is and I'm just going to not have a database right now, and that's what the Prisma requires. Let's see if this works. That's something that I'm going to have to take a look at, but looks like it's now working fine. So I apologize for that little detour, but when I ran my ChainLit app, what it did was it opened up a little server here for me, and this available URL you can actually share with people on Gitpod. And right now, I'm just going to ask a simple question. You know, what's the weather today in Washington, D.C.? And, you know, if I ask this question to OpenAI, it really wouldn't, you know, have the right answer. So what it did was it actually figured out that it didn't have the answer in the LLM, and it went to a tool called search, and it searched, it got some data. And there's some issue with this, you know, could not parse LLM out, but that's fine. I mean, I can show how to fix that later. But at least it told me that there's the DC's 86 scattered thunderstorms, and I can verify that, right? I can go to weather.com. Hopefully there's not too many crazy ads on here. And I can say Washington, D.C. That's crazy ads. I don't know who does their ad buying. Thank you for being so slow. Okay, there we go. So yeah, it's 85, partly cloudy, severe weather. So yeah, it's pretty accurate, right? I can also say, you know, who is visiting with President Biden today from Israel, right? Because I know there's a guy from Israel here. So what it's going to do, it's going to realize that it's not able to really, you know, get the answer from itself, and it's going to do a search, and it's getting some answer, right? Now it's doing a couple of different things. It actually it got the answer, right? But it crapped out. So this is the part of an agent that sometimes we can't you know, control. Now it really did get the answer, right? Up here, right? And it said visit to the so it wasn't today, it was yesterday, right? So it got confused and it said, well, see who's coming, and it kept going, and finally it was like, well, I can't get the answer, so I'm going to go to Foursquare to see visitors and really just crapped out. So this is the part of the agency that I was saying that it's not always exact, and it hit a limit with OpenAI. So we can tune the use of tools when I show you the code. So what I have here is a working LangChain application that's doing basic retrieval augmentation with search, and it's doing some agency, meaning it's talking to different systems depending on what it seems to use. So what I like about ChainLit is it's taking what LangChain would be outputting if I was running LangChain in this view, and it's letting me see how this kind of went through. And I can actually go in here and see what prompt was sent to the LLM to get that answer, right? That's pretty cool. And ChainLit is a free open source tool. And the only code, let's just switch gears. The only code that I have in, I'm going to just stop this real quick. In the ChainLit is, here's my, LangChain libraries. This is using the LangChain factory from ChainLit. And I have actually put in here things like my search tool, which is built into LangChain, my math chain, which is built into LangChain, a Giphy wrapper, which I got from the original version of this code, and I tweaked it, the Foursquare wrapper, which I wrote, and then I'll cover this in a second, which is the knowledge wrapper, which is my data, right? But just having these tools is not good enough. I have to then tell LangChain which tools to use in sequence. It tries to find the most relevant thing. So useful for when you need to answer questions about current events. Okay, you should ask targeted questions. Useful for when you need to answer questions about math. Then Giphy is about pictures. Foursquare search is about a particular place. Foursquare near is about a particular place in a particular location. I have and this is my stuff from my knowledge base, failed bank list, and text from a short story, right? Now, if I look at this tool chain, I could really just limit it by saying, you know what, I don't want my LangChain to use anything except for, let's say, search and calculator, right? So I'm just going to cut that. And I actually have most of this in my comments, but I'm just going to save it, make sure I have it. So my ChainLit app is basically about 40 lines of code, and it has comments. So technically, it's really not 40 lines of code. And if I were to rerun this, so actually, I like this view a little bit better, right? So now if I asked you know, who is visiting President Biden today from Israel? Okay. And we'll see what it does, because I turned off the Foursquare. It's really not going to be able to use it, right? And you know what? It actually, you know, it kind of made up this answer, right? Because it was actually yesterday, but it made up. And this is basically the LLM interpreting it, right? It took the answer from Google, and it used that information. If I ask it a math question, you know, what's the hypotenuse of a triangle? What's the length of the hypotenuse of a triangle with a length of 10 and a width of 20? Now, the LLM itself could do that, but we know that math chain is going to be better. So what it did was it took my question and it used the calculator to create code, and it got an answer and gave me back this answer. So this is, again, a little bit of the agency that LangChain gives us. So pretty cool. Now I'm going to go ahead and put back some of the other tools that I took out. So for example, I'm going to put everything in there except for the knowledge base that I created with the failed bank list. And with, I think that's something off here. There we go. And again, what I like about the ChainLit is, as I'm changing code and I'm saving it, it's refreshing in my browser. And I can ask a question like, what's a great place to have a business meeting in the Georgetown area of Washington, D.C.? Technically can get an answer from the LLM itself, from its previously gathered data. So what it's actually recognized is that Foursquare is a better tool, and it went ahead and looked for business meeting near Georgetown, and it got some answers back. Unfortunately, it just searched for business meeting, and these aren't really places to meet. Maybe except the McDonough School of Business, because they have some places to meet there. So I'm going to ask it a different question. What's a great place to co-work in Washington, D.C.? And it's probably going to just figure out that it needs to look for co-work. So just while it's doing that, right? It found all these from Foursquare as JSON. It did an API call. It formatted it as text, and then it understood the text to summarize it to give me this answer. And the same way, it's, you know, it found co-working spaces, did a search on Foursquare, analyzed it, got these answers. And you know what? These actually aren't bad places. I've been there. They're lobbies, they're hotel lobbies, but they likely have in their reviews or somewhere in Foursquare that it's a place to co-work. Okay, so we're able to extend our conversation with the LLM with these outside systems. Now, what if we wanted to use our own data? And that's where Llama Index can come in, but LangChain also has the ability to take data that we have and put it into a database, into a vector database. And in our case, we're using Astra, which is an infinitely scalable database, and now they have vector search. I actually have previously loaded data into a database called Iris. And I'm just going to show. And if you're familiar with SQL, Cassandra is actually, the syntax is very similar. You don't have to be like a specific, you don't have to change your skill set. You can use SQL. So let's see, I'm going to say select star or count from chat is my key space. And I got my text. So there's about 33 records, and actually, you know what? I'm gonna just show what's in here. And a lot of data comes back, but what I basically have stored in this database is the text and the embeddings of that text, okay? And I actually don't care about these numbers, but the similarity search that we need to do a vector search needs these numbers, okay? And the data, I loaded it from a text file. I have another table which has data that I loaded from a CSV file. A lot more data in there. And again, it's structured data, came from a CSV, but it also has the vectorized data. So I don't need to look at everything. Okay, so I know I have data in a database. To show you what this data looks like when it was raw form, it's basically this file right here. It's a short story, right? Could you fit this inside a LLM prompt? No. That's why we chunk it into small parts and we save it into a vector database. And I'll show you how we did that. This data, could we give it all of this in one prompt? Probably not. So that's why we chunk it into different rows, and it finds, using vector similarity search, it finds similar documents and then sends it to the LLM for processing, for understanding. So the code to do this, I'm just going to do a quick review of it, but I really just want to turn on the knowledge base in my tool and then show you how we can ask questions. So and I'm likely going to separate this into two files, but basically we're loading data with a few lines of code saying, here's my text file, right? And put it into Cassandra. Here's my connection information. Split it, which you need to split, documents if they're big. And when we talk about Llama Index, I'll go deeper into why we need to split. Versus a CSV, we don't need to really split it because it's already kind of split by rows, right? So we don't have to split it. Each line is kind of a different document by itself, and it puts the data in there. Okay, and the rest of the code here is basically exposing that data as two methods. So there's a Banks method and there's an Amontillado method, and that's what our LangChain is actually going to use. It's just going to run those methods for us. So I copy the failed bank list. So note that I'm calling this tool failed bank list. Run this method for Amontillado. Run this method. And you notice how it says, return true, return direct true. This just means that whatever answer the system gives me, go ahead and give it back. Don't need to do further processing. So if you remember when we were doing some searches through the chat, it was saying could not parse LLM. I could basically say, just return the stuff. You don't have to parse it, okay? And the context I've given it is, useful for we need to find information about failed banks. And you can put in the year or the banks, right? Useful for we need to answer literally questions about short story, right? So just ask a targeted question and it'll find similar documents. So having done this, it should already be in here. So if I scroll back down here, okay. So I'm just going to say, what banks failed this year? It apparently doesn't know what this year is. Thought about it, thinks that it's 2021. So now it's in an infinite loop. I'm just going to stop this task and I'm going to say, what banks failed in 2023? I wonder, I guess there was no failed banks in 2021. Okay, so said couldn't do it. So I'm going to be a little bit more specific. I'll say, tell me the failed bank. Tell me which banks failed in California, have failed. There we go. When did Silicon, I guess Silicon Valley should also be in there. Bank fail, and where is it located? So, although I've been asking, relatively simple questions, I can give it very complex questions, and it can break down each part of the question and use different tools, right? That's one of the benefits of using something like LangChain. It's intelligently choosing the tools that it needs to use. Then also ask another question, what's the plot, or who is the protagonist in the cask of Gelato? So yeah, protagonist is Montresor, right? Who is, tell me a little about Montresor. Apparently just went to it went to Google and looked for an answer. But this is a simple example of using LangChain with retrieval augmentation, both from just outside APIs, as well as my own data. In the next session, we're going to use Llama Index to do the same thing and see if that improves the results, because Llama Index has more robust handling of vectorization and asking questions from vectorized data, including something called forward-looking, retrieval, which is cool as hell. So looking forward to showing that to you all next week. I encourage all of you to pull down the code, join the Discord, and ask questions and learn this for your own benefit. Thanks, everybody, and see you guys same place next week. Bye.